Welcome back to our lesson. The first one is going to start with integration. Now, integration is the reverse of differentiation. The process entails finding functions from their gradient. So integration is the process by which one can find the functions from their gradient. For example, integrate the following function and express it graphically. Now, we have the function 2x raised to power 5. So for us to integrate that function, we must have the integral of the sine f of x dx is equals to m raised to power m plus 1 over denominator m plus 1 plus c. So that is the formula that we use for integration, f of x of dx. So f of x is equals to, as you can see, the integral into two terms, x raised to power 5 dx, of which we going to have 1 is added to that 5 to be 6, x raised to power 6. And then that 6 is going to be expressed in the denominator, whereby 2 is going to go to that 6 at 3 times. That's why you see a third x raised to power 6 plus c. Now, plus c is going to be the y-intercept. A question must be written plus c. Now, that's why we must have plus c must be there. So that's for the integration. A third x raised to power 6 plus c. Now, let's go and see in our graph. Let us write that equation. We can say the equation is we can have the integral, and then we can have the integral of the function 2x raised to power 5 and see what it brings there. So that's the question. That is our graph. We have expressed that graph in that particular form. As we can see also, let's see that it is a third the function now after doing integration. F of x is equals to 2x raised to power 5 dx. So let's write that equation in this particular form, as we can say. And we have to say that for the integration, the equations must be written. So we can have a third, and then we can have x raised to power 6, then plus. There must plus c. Plus c is necessary for us so that the y-intercept, the coefficient of the y-intercept is going to be c. Now we can see we have the first one. The first one was our original graph, and then we have the second one. It's also for the function which is we have the blue one is for the function which say that have a third x raised to power 6 plus 1. So at that particular point, the y-intercept is 1. But the original one, it was a third x raised to power 6, the one which is in red, a third x raised to power 6. But now when we had plus c, that's the y-intercept. Let's see what happens to the graph when we have the movement in the y-intercept. Let us see. So you can see that it's going to move up positive when the y-intercept is positive, up, and down negative when the y-intercept, that is constant c, to be what? Negative. So you can see the movement of that curve. So the curve which is moving there has a constant. That constant can either be negative or positive. When it is positive, it moves. When it's positive now, as you can see, it is moving up because we are moving to the positive number of the y-intercept. It moves up to 5, and then it is when it's negative, y-intercept negative, the curve moves down. The curve moves down, as we have seen. And then you can come back and look at the equations there. So the equation that we have done, we have integrated that equation, and we have seen how the curve moves. So another equation says Find the equation of a curve whose gradient function is dy over dx is equals to 2x plus 3 and passes through point 0, 1. So now dx over dx, dy over dx is equals to 2x plus 3 gradient function. Now it was differentiation, as you can see. Now that curve, we have to find the original curve that we need to draw on our graph. Now we say that for us to find that original graph and passing through the point 0, 1, it means that we have to integrate that particular function so that we can find the original function. So we are going to integrate the function so that we can find the original function to be plotted. Now, f of x is equals to 2x plus 3 dx. So that's the way we write it. F of x, as we said, for the formulas for the integration, you can see that 2 x squared over 2 plus 3x plus c. C must be a constant. That's why we express integration functions. Now you say y is equals to x squared plus 3x plus c. And the point says 0, 1. Because the curve is going to pass through that point, so we say that we have integrated that function to find the original function to be plotted. Now, at that particular point, the 1 is the y-intercept, of which it's going to be of that of c. 1 is equals to 0 squared, because the value of x now is 0, plus 3 times 0 plus c. You can say that 1 is equals to c. Thereby, the equation that we need to plot on our graph is going to be y is equals to x squared plus 3x plus 1. So we say that the reverse of differentiation is what we call integration, and vice versa. So we have done what we call integration, and we have found the equation that we're going to, or the function that we're going to plot on our graph. So the function that we're going to plot on our graph is equals to y is equals to x squared plus 3x plus 1. Let's come to our graph and plot it. So you can come to our graph there and say, let's bring that function nearer. So the function is y is equals to x squared plus 3x plus 1. So let's say when we're going to plot that point, we can also come with special points on our graph. These are the points we're going to use for plotting that graph. So we can have, let's see our graph there. Let's go and plot our graph. So that's our graph that we have plotted. So you can see from the points, let's see, point C, let's give it a nice look. So we can have that one. So you can give it a good nice. So for those points to be seen clearly. So that's how we do that particular equation. So that is the equation that we have drawn for that particular function. As you can see, we have the point z. C is negative 0.380. D, you can see it. D is here. That's our point D. It is negative 2.60. We have E, we have F. Those are the special points that we can use for plotting our graph. So we have drawn our graph, and then we have seen it. And then let's see where that particular one, the y-intercept, comes from. As you can see from there, from this particular graph, the point there at F, this particular F, it is the point there. The point there is going to be called, you can see the y-intercept 0, 1, 0, 1. As you can see from that particular, the equation that we have, y equals to x squared plus 3x plus 1, you can see that that one comes, and then we are going to have it here. So y-intercept equals to 0, 1. Yeah. Another equation we can come to another equation and say, so you can also have another equation of which we're going to have question 3. Find the area of the region bounded by the curve. Area of the region bounded by the curve y is equals to x cubic minus 3x squared plus 2x. The axis x is equals to 1 and x is equals to 2. Now the question needs us to draw that. We can also draw that curve to see it, and then the region at which that curve is going to lie. They have said that x is equals to 1 and x is equals to 2. That's the region, the area of that particular curve, or the region where it's going to lie between x equals to 1, x equals to 2. Now, what we need to do is for us to find the area, we must do what we call integration. We cannot go and do differentiation. We say we must do what we call integration. Now, f of x from the integral, as we can change it, you can see at the end of the day, you can have x raised to power 4 over 4 minus x raised to power 3 plus x squared raised to power 2, and then we have 1 there. So the 2 and 1 are going to be the coefficient. Now, the range. 2 is that range, the highest range, and 1 is the lowest range. So the x variables, we're going to replace them with 2 and 1. So as you can see here, we have the first one, as you can see that one. So we have 2 there. So this x, we're going to replace it with 2, as we have replaced there, and everything x inside we're going to place with 2. And then we do that particular substitution. The same to this one, other. Now, this x, we have also 1, the one that we are going to replace there with that x. And we're going to do some addition, subtraction. So it's very easy. For the first point is going to give us 0 minus the second point. The answer that we get is 0.25. Now, when this, we have to do what we call subtraction, so that we can find that range where the curve lies. So we're going to find negative 0.25. So that tells us that the area of that curve is below the x-axis, because that's why we find the area to be negative. But area cannot be negative. The area must be expressed to be positive. Now, that's why you say 0.25 units. 0.25 units. That's the area of our curve. Let's go and see that curve where it appears. So we can just go there and draw our curve. We can say the curve now is going to be, you can never draw a curve after integration. Now draw the curve of the original. Say y is equals to, let's say y is equals to, we can have x cubic, and then we can have minus 3x squared, and then plus 2x. So let's see our graph, the way it appears. So that's our graph for the function of which is going to be y is equals to x cubic minus 3x squared plus 2x. So at the point, the question says for the point x-axis is equals to 1 and 2. Now let's see our graph from there. At that particular point, that's where they are saying, and then this particular point. As you can see, the region that we're going to calculate the area is below the x-axis. Now, between the point, this one, 1 and 2. Now, this is the area. At this particular point, as you can see, that's the area we're going to calculate. By calculating that area of that region, and then we are going to use what we call differentiation. So, by the use of differentiation, we can able to do that particular question. As we can see, now our area of interest is finding this particular point. At that particular point, we can say, and you can see it clearly. Let's see that particular point clearly. Now we can come there. So this is the point that we're going to find in this area. So the area of that particular point, by use of integration, that's how we can find it. That's how we can find that particular area. That's how you can find that particular area. This is the point. So that's how we have done it by the use of integration. Thank you for watching. Subscribe for more mathematics and follow up uh, as we grow together as a society.